Hey guys, welcome back to my CCNA 200-301 course. In this video, we are going to review IPv4 Basics. Are you ready? Let's get started. IP stands for Internet Protocol. So far, we've had two versions of this protocol, IP version 4 and IP version 6. IP version 5 has never adopted as a standard protocol. So we got 4 and 6 only. And in this video, we're going to review IP version 4 basics. IP addresses are similar to mailing addresses. So with this definition, each IP packet will be just like an envelope, and the routers would be like post offices, which decides where envelopes or IP packets should go. We will talk about this later when we talk about the routing stuff. Each IPv4 address is 32 bits. And this 32 bits has divided into 4 different sections. So we have 8 bits per section. So each section is called an octet or a byte. Machines work with this address with zeros and ones, but we as humans cannot deal with these large number of zeros and ones. So we actually present this 32 bits in decimal notation, like 192.168.1.1 as depicted in the slide. So this method of notation is called dotted decimal because we put a dot in front of each section. 192.168.1.1. Each IPv4 address logically divides into different parts: network ID and host ID. Network ID is the same for all hosts within that network. But as we said before, each computer should have a unique IP address. So this is the host ID part that is unique for each host. But how we can determine which part of our IPv4 address belongs to network ID part and which part of it belongs to host ID part? IP by itself cannot determine that and cannot show us. So we need something else. And that something else is called subnet mask. This is the subnet mask that determines which part of our IPv4 address is network ID and which part of it is host ID. So subnet mask, just like the IPv4 address, is a 32-bit address, but it's got its own rules. The major one is subnet mask starts with ones, and when ones finish, then the rest of the subnet mask will be zeros, like the one you see in the slide. But we cannot have something like this. It's not gonna happen. But the question is, how does subnet mask does its job? As its name shows, it masks the IP address. So if we mount the subnet mask over the IP address, these are the ones that determines which part of our IP address belongs to network ID and which part of it belongs to host ID. The part that masks with ones belongs to network ID and the rest will be belonging to host ID. So in this example, you can see that we got 24 ones. So if we mount these 24 bits over our IP address, the first 24 bits will be network ID, which is 192.168.1. So all hosts in that network will have 192.168.1. So we got 8 bits to generate unique IDs for our hosts. So with this definition, we can simply determine the number of hosts that we can have in a single network. And it comes from this formula. 2 power to the number of host ID bits, or the number of zeros in the subnet mask, minus 2. So for the example that we had in the previous slide, we will have 2 power to the 8 minus 2, which will become 254. So we can have 254 addresses in that network. But what is this -2 for? This -2 is for two addresses that we cannot use them in each subnet or network. We cannot have an IP address which has got all zeros in host ID part, because that one is reserved for network address. When we want to point to that whole network, we will be using this address, and we need it too much in routing. And also, we cannot use an IP address which has got all ones in the host ID part, and that address is called broadcast address. I will talk about the different message type in IPv4 in next videos. But for now, you just know that we cannot use two specific addresses per network. IPv4 has got 5 different classes, and this is the first octet that determines the class of our IP address. If the first octet of our IP address is a number between 1 to 126, our IP address will be in class A. If it is something between 128 to 191, it belongs to class B. And if it is something between 192 to 223, it will be in class C. If it is something between 224 to 239, it is in class D. And if it is something between 240 to 255, it belongs to class E. Each of these classes, I mean A, B, and C, has got their own default subnet mask. For class A, the default subnet mask is 255.0.0.0. For class B, it is 255.255.0.0, and for class C, it is 255.255.255.0. For classes D and E, we don't have subnet masks, or it's not applicable for these ranges, because basically class D is for multicast. It is another type of message that I will talk about it later in next videos. And finally, the class E is called experimental. This is the actually former name, and the new name is reserved. So we cannot use these IP addresses in our networks. If you look at this chart, you may ask, so where is 127? 127 is reserved for a specific address, the whole range actually. Whatever starts with 127 is reserved for a specific address, which is called loopback address. And this is the address that has been set on all network adapters for internal stuff. There is a simpler way of presenting the combination of IP address and subnet mask. And in some devices, we can use it for configuration as well, not only for presentation. And it is called prefix notation. With prefix notation, we write our IP address, and then in front of it, one /, and then in front of the /, we write down the number of ones in the subnet mask. For example, we will have 192.168.1.1/24, which means that our subnet mask has got 24 ones in it, and it would be 255.255.255.0. And also, if we are in a classful context, we can say IP/default. So we need to refer to that actually classes and their default subnet mask, and then we can figure out what is the default subnet mask for that IP address. It is rarely used, but you can use it in classful contexts. As I said before, internet uses TCP/IP, and we also use TCP/IP in our local networks. So how we can guarantee that there will not be any IP conflict around the world? Actually, IETF defined RFC 1918 to segregate local networks from internet. And in that RFC, it defined the private IP addresses. So basically, public IP addresses or valid IP addresses are the IP addresses that are routable with internet routers. But internet routers do not route private IP addresses, and we can use private IP addresses in our local networks freely. IETF defined 3 different ranges in RFC 1918. The first one is 10.0.0.0 to 10.255.255.255. The next one is 172.16.0.0 to 172.31.255.255. And the last one is 192.168.0.0 to 192.168.255.255. The CCNA topic that we have covered it in this video is number 1.7. Describe the need for private IPv4 addressing. Alright guys, this was our today's video. If you enjoyed it, please do not forget to click on the uplink and subscribe to the channel. Put your comments down below and like the video. Thanks for watching.